Good afternoon once again. This is 1000 ways of solving mathematics. Today we are looking at physics. Under physics, we are revising on Newton's laws of motion. So just a quick recall on the first law, which states that every body remains at rest or moves with uniform velocity unless it is made to change this state by external forces. Every body remains at rest or moves with uniform velocity unless it is made to change this state by external forces. So what does it mean here? If there is no any external force to act on a body, it means that body continues to move with uniform velocity or remains at rest without any external force acting on it. It remains in that state. So that is the first law of motion. Okay. Now let us summarize this first law, or rather by using the first example. So example 1 reads, a horizontal force, that is force of 0.5 Newton, acts on a body of mass 0.2 kg. There is a friction force of 0.2 Newton opposing the first force. What acceleration will be produced? A horizontal force of 0.5 Newton acts on a body of mass 0.2 kg. There is a certain friction force of 0.2 Newton opposing the first force. What acceleration will be produced? Okay. So here the situation is we have a situation like this, and we are told that this is a force, the acting force of 0.5 Newton, okay, which is acting on this body of mass 0.2 kg. And now there is a certain friction force, this is 0.2 Newton, which is now pushing this body against the acting force. So the acting force, the applied force, is actually a 0.5 Newton, which is actually acting on this body of mass 0.2 kg. And there is another force, a friction force, which is acting on this same force of 0.2 Newton. Now, understanding that a friction force is actually the opposing force. So you can see the force which is acting on this object is moving actually in that direction. And there's another force which is actually disturbing its movement by acting this direction. So how do you find the resulting force? So in this case, the resulting force is what we have to find first, will be equal to the acting force, which is 0.5 Newton, minus the friction force 0.2 Newton. So meaning the force we are looking at now is actually 0.3 Newton. Okay. So under this circumstance now, we are told to find to calculate the acceleration which will be produced. So what acceleration will be produced on this actually kind of a situation? We have a force which is acting on a body of a body of 0.2 kg, and a friction force actually which is 0.2 Newton. Now, so the first thing is we find the resulting force, which is a 0.5 Newton minus the friction force, which will give us a 0.3. So from here now, we apply the formula from the first laws of motion. We can recall that we have F is equal to ma, so we can use this one. where F is the force, M is the mass, and then A is the acceleration. So we are finding the acceleration. We can actually make A the subject of the formula, so over M over M. So that gives us A is equal to force over mass, and A is equal to the force, which was 0.3 Newton over 0.2 kg. So that we now have that is A is equal to 0.3 times 10 over 0.2 times 10. So this gives us 3 over 2 if you want, that is Newton per kg there, meters per second squared, that is if it was the case. So in this case it is 1.5, okay, 1.5. The remainder is 1, that is 1.5 Newton per kg. So that will be the acceleration there.